Hello, my name is Pat Hannon. I am the Chief of Academic Development for United States Air Force School of Aerospace Medicine. Today we're going to talk about 4 topics. Those topics are the cognitive load theory, the cognitive theory of multimedia learning. I'm going to talk to you about reducing extraneous processing, and then I'm also going to give you a demonstration on refutation. Cognitive load theory is the processing of information from your sensory memory to short-term memory and eventually into long-term memory. There are 3 types of cognitive load. There is intrinsic cognitive load, which is due to the natural complexity of the material that is being presented. In other words, the subject matter that you're being discussed, it has its natural complexity to it. Without adding anything else or any distractors in it, it is normally complex. The second type is extraneous cognitive load. Extraneous cognitive load is due to inappropriate instructional design and then designs that have unnecessary information in there, and it increases the number of interacting elements. In other words, there's too many things on the screen, or it's presented in a way that the mind has to think about too many different things. It draws the student's attention away from the subject matter that they're trying to learn, and they're focusing on trying to figure out all the little pieces that are being presented. And the last one is germane cognitive load. In germane cognitive load, it's also known as effective cognitive load. And this is your working memory resources that are devoted to the intrinsic cognitive load. A simple math is you take your intrinsic, subtract your extraneous, and you get your germane. In other words, this is what's left over when you take the extraneous away from the intrinsic. Next thing we're going to talk about is the cognitive theory of multimedia learning. And it is said that people learn more deeply from words and pictures than from words alone. With this, there are 3 assumptions. The first assumption is that there is a dual channel. Humans process separate information through 2 different channels. You have your auditory and your verbal. In other words, your eyes and your ears. And by using multimedia and using these 2 different channels, you can actually get more information in without overloading your working memory. However, the next assumption is that there is limited capacity. So even though you have 2 sensors that are working, they both still have a limited amount that they can take in. The other thing is that if you bring too much in through the eyes, they're going to stop listening. Or if you bring too much in through the ears, they're going to stop looking, and they're going to try to focus just on the one sensor. So again, even though you can bring more in, you still are limited. The last assumption is that you have to have active processing. In other words, the student has to actively be engaged in the cognitive process. They need to be trying to learn what you're teaching. If they're daydreaming, focusing on something else, it doesn't matter how well your presentation is done. It doesn't matter how well you've gone and made sure you're not overloading anything. If they're daydreaming, they're not going to get it no matter what. The next thing we're going to talk about is reducing some of that extraneous processing. And again, remember, extraneous is the stuff that's distractions. These are the things that are going to take you away from learning the material we want you to learn, and it's going to get your mind off into nowhere land. The first way we can do this is through signaling. Signaling is when you use cues. In other words, you have an image on the screen or you have text on the screen, and you want to draw the student's attention to a specific area. Some of the ways that you can do that is you could highlight certain areas or change the color of the font. Other ways, if you have an image that you want to highlight, you can actually label the items that you want them to focus on. Therefore, they're not looking at the entire image, they're only looking at the part that you're wanting them to see. It's actually better to label it right on the image rather than labeling it off to the side and drawing the arrows in. Or if you do use the arrows, use very short arrows. The next way to reduce extraneous processing is through the redundancy principle. Okay, and in redundancy, when you have graphics and printed words and narration going on all at the same time. In other words, you have your graphics, which you're using your eyes, you have printed words, which you're using your eyes, and you're doing the narration, you're going to be overloading. Again, we talked about there is a limitation even when you have the dual processors. So it is actually better to have the graphics and narration alone without the written text. This way, the eyes are focused on the image, the ears are focused on the narration, and we're not going to overload your short-term memory. And then the last type, or the last principle in order to reduce extraneous processing is through spatial contiguity. This is where the images and the words are close together. Have you ever read a textbook where you have an image on page 12 and they refer to it on page 15? You got to flip back because you obviously don't remember what that image was. It's best if you do these images where the image is right there and then right below it or right next to it is the text that applies to it. Again, if you don't do that, the student actually has to remember what the image looked like as you're describing it. Or vice versa. If the image came afterwards, they got to remember what you say when they go to look at the image. And again, that's spatial contiguity. The last thing we're going to talk about is we're going to talk about learning through what is called refutation. And I'm going to demonstrate what it is, but first I'm going to tell you what it is. Okay, refutation is learning through refuting some of the current beliefs. In other words, your students come in and they have a certain belief about something. They know something about a topic. And you are actually going to, not argue, but bring up a different point of view. You're going to refute their position. And then you're going to give them an explanation of why they should accept this new information. And there's three ways that you do that. Or I'm sorry, there's three parts to that. There's the misconception, there's the refutation cue, and then there's a currently accepted scientific explanation. In my example, I'm going to talk to you about, we have two courses here. We have the flight nurses and the technicians, and then we also have our flight docs that come to school here. When the docs, nurses, and technicians come here, they believe that they know how to take care of the human body. Okay, so the misconception is doctors, nurses, and technicians know everything there is to taking care of the human body. My refutation is that they may know how to do it on the ground, but they don't know how to do it at altitude. Okay, so what I'm going to do then is I'm going to present them with new scientific explanation. And the scientific explanation is very simple. It's that the human body reacts differently to injuries, medication, and treatment at altitude. So where we get the students, they are already doctors, nurses, and technicians. We are going to make them flight docs, flight nurses, and aerovac medical technicians. So we're going to teach them how to do what they already know at altitude. But in order to do that, they have to admit that what they currently know isn't right for what goes on up at altitude. Today we talked about the cognitive load theory. We talked about the cognitive theory of multimedia learning. We talked about reducing extraneous processing, and I demonstrated refutation. Thank you very much.